Hi guys, so for today's discussion, we have line balancing using the number of followers method. Now for our problem, an operation has the following activities given on the table within or with their respective time of completion in minutes. The production department received an order of 800 units and must be produced within the 120-hour available time. So we are given the following table of the tasks and their precedence requirements along with their duration of completion in minutes. Now, before we proceed with the line balancing, so we first need to draw the precedence diagram or the task diagram for us to be guided on what tasks should be inside a specific station. Now, here is the task diagram showing the flow of the tasks along with their respective task times in minutes. Now, as a review, we have the following constraints in line balancing. So, the first one is the cycle time, meaning a specific station cannot exceed the desired cycle time from the formula of your required output and our available time. Then, the second constraint is the precedence requirement. So, again, we cannot begin a task hanggat hindi pa natatapos yung task na before siya gawin. Now, going back to the example, so, ang given dito is our required output of 800 units and that the available time is 120 hours. So, for our solution, let's write the given information. So, yung output is 800 units while the available time is given as 120 hours. Pero since yung ating task is given in minutes, so we will be converting the available time given in hours in 2 minutes. So kaya siya times 60 and this will give us 7,200 available minutes for the production. Now, the first thing that we need to solve is the desired cycle time or yung CD. CD or desired cycle time is by the formula your available time divide by your output. And this is 7,200 minutes divided by your 800 units. And this will give us an answer of 9 minutes per unit. The next thing that we need to compute is the theoretical number of stations naman. So that is N. By the formula, the sum of your standard time divided by your desired cycle time. Now, going back to the given example, so we must compute for the total standard time from the table. So, we will be just adding everything from the duration in minutes and the sum will be about 65 minutes. So that will be 65 minutes divided by your 9 minutes per unit. And that should give us a value of 7.22 stations. Or again, rounded up, this will be 8 stations. Now, take note that this is just the theoretical number of stations. So, sa actual na allotment natin for each station, so pwede pa siyang mag-exceed sa 8. So, as long as your actual stations for the balance line is not equal to or greater than the actual or the current number of stations in the given unbalanced line. Now, after that, So, we will be computing for the current efficiency of the unbalanced line. So, again, the formula for the computation of the efficiency is the sum of your task times divided by the current number of stations multiplied by the allowable cycle time. And again, allowable cycle time is the longest task time in the given problem. So, looking at our given values, the allowable cycle time is 9 minutes, and then we have a total of 14 stations. So for our current efficiency, again, that's the sum of your standard time divided by the current number of stations, and then we multiply by the allowable cycle time, and that is 65 minutes divided by 14 times yung 9 minutes na pinakamatagal gawin, and then we multiply that by 100 to get the efficiency in percent form. So that will give us 51.59% for our current efficiency. So now that we know the current efficiency of the line, we can now proceed with our method of the number of followers. Now on this slide, so you can see the different tasks along with their duration in minutes, and then the third column is the number of followers. So we simply count the number of followers for each task, and then sulat lang natin siya on that third column. Now, the number of followers method works like prioritizing the task na may pinakamaraming followers. Okay? So, let's proceed with the solution. So, again, we have the following guide for our station allocation, and again, from our previous solution, the theoretical number of stations is equal to 8. So, and again, yung ating cycle time daw is 9 minutes. So, ibig sabihin, each station should not exceed by 9 minutes. So, station 1, so, based on sa ating priority, si task A yung may pinakamaraming followers. So, ibig sabihin, siya yung dapat na ilagay doon sa station 1. Pero before that, we need to verify kung wala pa tayo na-violate na precedence requirement. Now, looking at our diagram, si task A naman ay walang sinusundan. So, it is safe for us to write A or put A in station 1. So, that's A. So, we have available minutes of 9, and then the duration of A is 2. So, minus 2. So, you'll have 7 available minutes. Next task na may pinakamaraming followers ay si B. Now, si B in our diagram, kailangan niya si A para siya ay magsimula. So, since A is already in station 1, so we can proceed with putting station B on the first station as well. So, we have B, and then 7 yung available time, and then 5 minutes yung task time ni B. So, minus 5, and that will give us available minutes of 2. So, next is yung may pinakaraming followers, which is si D. So, D has 9 followers, kaso ang duration niya is 5 minutes, and we only have 2 minutes na available time. So, we will be looking for other tasks na pwede natin ilagay kay station 1 just to maximize the cycle time for that station. So, looking at our table, right? So, we can see na si task I lang yung pwede kong ilagay since 2 minutes din yung kanyang duration. However, si task I cannot begin until magawa muna si task E and si task F. Since A and B pala yung nasa station, so we can now proceed with closing station 1 and proceed with locating or allocating tasks at station 2. So again, we will be reviewing the number of followers. So since tapos sa si A and si B, yung next na pwede kong i-allocate is si task D, which has 9 followers. So again, verify with our precedence diagram. So si D, kailangan niya lang si B, and si B is already done. So we can put task D sa station 2. Again, 9 minutes yung initial current available time minus the time for task D, which is 5. So that will give us available time of 4 minutes. Next will be yung may 7 followers, which is si F. So ang kailangan lang naman ni F ay si D. And F has 3 minutes, so pwede ko siyang ilagay sa station 2. That's 4 minus 3. So we'll have 1 minute available. And again, looking at the duration of the different tasks, wala nang pwedeng ilagay kay station 2 since max out na ito. Next will be station 3. So we'll proceed with scanning again. So, yung may 6 followers is si task E and si task G. Now, si E, kailangan niya lang naman si B, which is already done. So, since nag-tie si task E and si G, so again, we will be breaking the tie based on sa longest task time between the two, and syempre, without violating the precedence requirement. Now, si E takes 7 minutes and si G takes 3 minutes. So, 7 minutes yung mas matagal, which is si E. So, we can allocate task E kay station 3. That will be E. And 9 minus 7, that's 2 minutes available time. So, si G, hindi na pwede. Si I, ang kailangan ni I ay si F and si E. And F is already at station 2 and si E ay currently naka-allocate kay station 3. So, ibig sabihin, we can maximize station 3 by adding si task I. So, we will now proceed with station 4. Okay. So, again, reviewing. So, si E nakapasok na. So, next na may pinakamaraming followers ay si G. At ang kailangan ni G ay si D lang naman. So, pwede ko nang ilagay si task G. That's 9 minus 3. So, we have 6 available minutes. Then, followed by yung may 5 followers, which is H and I. So, between H and I, so 5 yung mas matagal gawin, or yung H yung pinakamatagal gawin, which will take 5 minutes. Again, verify with our diagram. So, ang kailangan lang ni H ay si G and si F. And we know that F is already done on the previous stations and si G is currently in station 4. So, pwede ko nang ilagay si H. That's 1 minute. So, again, wala na tayong pwedeng ilagay na task. So, we can now close station 4 and proceed with station 5. So, next will be the task with 4 followers, which is si J. Si J, ang kailangan niya lang is H and I is already done on the previous station. So we can now locate or allocate si J. So that's 9 minus 5. That's 4. Then followed by K, which has 3 followers. So ang kailangan lang naman ni K ay si J. So we can put K there. That is 0. So, max out na station 5. Let's proceed with station 6. So, next will be si M. Si M na mayroong 1 follower. So, si M, ang kailangan lang naman ni M ay si K. So, we can put M. So, again, max out na siya. Okay, so lahat ng may followers ay nailagay na natin. And ang natira na lang is yung mga task na walang followers. So, we will be beginning with station 7. So, between the tasks na walang followers, so we have C, L, and N. So, again, tayo sila doon. So, ang ating kukuhanin or yung pipiliin is yung task na may pinakamatagal na task time, which is si task N. And si N, ang kailangan lang naman niya is si task M, which is already complete in station 6. So, we can put the task N kay station 7. That's 9 minus 8. So, sarado na ulit station 7. So, proceed with station 8. So, ang natira na lang is si L and si C. So, si C yung mas matagal makomplete. So, that will be 9 minus 4. And that's 5 minutes. And then, si L naman is 3 minutes. So, pasok pa rin naman siya. So, we have 2-minute available time. So, reviewing. So, we can see na nailagay naman na lahat yung ating mga tasks sa 8 stations, which is in compliance with our theoretical number of workstations. So, summarizing our station. So, we have 8 stations with the following allocation of the different tasks. And after that, so this becomes our balanced line. So, yung ating efficiency, we can now compute for the efficiency of the balanced line. Again, that is your summation of your standard time. And then, yung ating critical number of stations. So, in actual value naman, 8 stations talaga yung na-compute natin. And then, again, we compute for the, or we include the desired cycle time. So, in this case, dahil na-max out naman lahat ng ating station, so we will be using 9 minutes pa rin. So, this is now 65 minutes divided by 8 stations times 9 minutes. And again, we multiply by 100 to get the efficiency in percent form. And that should be 90.28%. And if we want to compute for the effective output of the line, so that is yung ating available time divide by your effective cycle time. So, in our balance line, so yung longest time is your effective cycle time. So, again, reviewing 9 minutes pa rin naman yung ating naging effective cycle time. So, that should give you a value of 7,200 minutes divided by the effective cycle time of 9 minutes. So, ibig sabihin, through this balance line, we can achieve the desired output of 800 units. So, that ends the discussion for the number of followers method in assembly line balancing.